Okay, Unit 6 is about quadrilaterals. And quadrilaterals are just a special type of polygon. Polygon, if you remember back from when we talked about it in the fall, is just a shape with at least 3 sides. So quad means 4, so quadrilateral is a shape with exactly 4 sides. In other words, a quadrilateral is a kind of polygon or a type of polygon that has exactly 4 sides. But before we talk about quadrilaterals, we're going to talk just about polygons of all shapes and sizes today, and more specifically about their interior and exterior angles. Interior angles are the angles on the inside of a polygon. And the way we figure out how many degrees there are inside of a polygon is to draw something called a diagonal. Actually, we're going to draw more than one diagonal most of the time. So the reason we're going to do that is because they help us figure out the sum of the interior angles within a polygon. And again, the interior angles are the ones on the inside. So when I talk about interior angles, I'm talking about these. So just like when we were looking at triangles in the fall, and I would keep asking you guys, like, how many degrees are there in a triangle? You would tell me 180, right? What that 180 means is that if I add up all 3 angles within a triangle, they would equal 180. So we're going to do that with other shapes now, shapes that have more than 3 sides. Here's how we can do that. One way to do that is with diagonals. So a diagonal is just a line that goes from one vertex to a non-consecutive vertex. In other words, a vertex that's not on either side of it. So there's one diagonal I can draw, and the other one I can draw here would be like this. The reason we do that is because now we've broken up this 5-sided shape into 3 triangles. And so even if I don't know what any of these 5 angles are, I'll know how many degrees there are total inside of that 5-sided shape by just adding up the number of degrees in the 3 triangles that I've created. In other words, here I'm going to have 180 times 3. So 180 times 3, you can use your calculator or you can just take my word for it. It's going to be 540 degrees. So inside of any 5-sided shape are 540 degrees. Do the same thing over here. Break this shape up into, in this case, we have 1, 2, 3, 4, 5 triangles. So instead of 180 times 3, we would say 180 times 5. And 180 times 5, I believe, would be 900 degrees. So inside of any 7-sided shape, they're going to be 900 degrees. What I want you to do is, with these 2 shapes down here that I haven't marked in, that are on your note taker, I want you to pause the video, take a second, try and draw on the diagonals, and see if you can get figure out the total number of degrees inside of them. All right, so for the one on the left, all you can do really is draw one diagonal, right? Because we don't ever want diagonals to cross. We don't want that. So you could either draw this one or you could draw this one. But either way, you're only drawing one diagonal. So you're going to break this 4-sided shape up into 2 triangles. So you have 180 times 2, which is 360 degrees. That's going to be kind of important because this shape here that I'm looking at right now is a quadrilateral, right? It has 1, 2, 3, 4 sides. Inside of any 4-sided shape are 360 degrees. And again, right now we're talking about interior angles. So I don't know exactly how many degrees there are in any of those 4 angles that I just drew in black, but I do know that if I added the 4 of them together, I would get 360. The one on the left, I can draw 3 diagonals, which breaks it up into 1, 2, 3, 4 triangles. 180 times 4 is 720. So inside of any six-sided shape are 720 degrees. There's also a formula that you can use, and some of you will like the formula better than drawing diagonals, and that's fine. Either way works. Formula for figuring out how many degrees there are inside of any polygon looks like this. This D equals 180 times n minus 2. So D is sort of the answer. D is the number, the sum of the interior angles within a polygon. And n is sort of the information you need to know to figure that out. So n is going to be the number of sides. So if I work with that equation down here, I can see that this shape has 1, 2, 3, 4 sides. So if I want to figure out how many degrees there are in this shape, well, I already know there's 360, but if I want to use the formula to do it, I would say D equals 180, and then my n here is 4 minus 2. So 180, 4 minus 2 is 2. 180 times 2 is 360. So I got the same answer I got before, which is good. I can use this formula for the shape on the right. 6 sides total. So now my n is going to be 6. Yeah, instead of that n, I'm going to write a 6 minus 2. D equals 180 times 6 minus 2 is 4. 180 times 4, 720 degrees. Okay. That's for interior angles, angles on the inside of a polygon. Exterior angles are different. Exterior angles are if I take a side and extend it out, and then look at the angle created by that extended side and an adjacent side. So if we want to write a definition for exterior angles, they are created by an extended side and a side that's adjacent to it. Okay, so an exterior angle. What I want you to get out of your heads right away, if you're going there, is that an exterior angle is not this whole thing, right? Exterior angle is not from one side to the next side on the outside. You have to extend a side out and then measure the angle between that extended side and the side next to it. Okay. One kind of neat thing, I don't know if it's neat, but one lucky thing about exterior angles is that no matter what shape you have, no matter if it has 4 sides or 100 sides, the exterior angles, this only works for exterior angles, they always add up to 360 degrees. So no matter how many sides you have in your polygon, if you add up the exterior angles, they're always going to add up to 360 degrees. So if I call this A, and this B, and this C, and this D, angle A plus angle B plus angle C plus angle D will be 360 every time. Again, whether there's 4 sides or 100 sides, doesn't matter. All right, last vocabulary thing, regular versus irregular polygons. Regular polygons are polygons that have the angles inside are congruent to each other. In other words, all 5 angles inside of this pentagon here are going to be exactly the same. Irregular polygons, on the other hand, are any polygon where the measure of the angles inside of it are not all the same. Right? So again, regular polygons, all interior angles are congruent. irregular polygons, all interior angles are not congruent. Okay, in this video I'm going to show you how to do problems that are like the ones that you're going to have to do for homework or classwork. This one is going to be like numbers 3 and 4 on page 427. Okay, so it wants to know the measure of each interior angle, and so it doesn't want to know just what x is, it wants to know what angle Q is, what angle R is, what angle S is, and what angle T is. All I know about them right now is that they're represented by these expressions 2x plus 5, x, 2x plus 7, and x. Anytime I want to solve for a variable, I have to set up an equation. So the first thing that should pop into your head is I'm going to need to set up an equation of some sort. Now I have to figure out what's going to go on either side. Well, on one side, what I know is that if I have a four-sided shape, this is from the last video, what we figured out is that four-sided shapes, if you add up their interior angles, you get 360. So inside of a four-sided shape, they're 360 degrees. I don't know what these angle measures are right now, but I do know that I can represent them as 2x plus 5, 2x plus 7, and then an x and an x, right? That's just this, 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 and this. So I know what the four angles are in terms of x. Now I'm going to solve for x. Okay, before I start adding and subtracting things, I'm going to combine like terms. So if I add those together, I get 2x plus 2x is 4x, 5x, 6x. And now if I add up the constants, I have a 5 and a 7, which is 12. So my equation now is 360 equals 6x plus 12. And now it's pretty easy to solve from here. Subtract 12 from both sides. 348 equals 6x, divide by 6. 348 divided by 6. 58. X is equal to 58 degrees. Okay. Again, I don't want to stop here because I want to know what angle Q, R, S, and T are actually equal to. But I do know what R and T are, right? Angle R is just X degrees. So angle R is going to be 58. And the same thing with angle T, right? It's just X degrees, and I know X is 58. For Q and S, I'm just going to have to do a little bit of substitution. I'll do that in a different color. Angle Q is 2x plus 5. Well, I know that x is 58. So I can substitute a 58 in there. 2 times 58, 116. 116 plus 5 is 121. So angle Q, 121 degrees. And then I have to do the same thing for angle S. I could go through the whole entire equation and substitution thing again, or I can just look at the two expressions. When I did 2x plus 5, I got 121. If I do 2x plus 7, I'm just going to have 2 more than I had before. So angle S is just going to be 123, right? I would do the same thing as I did for angle Q, but instead of adding 5 at the end, I would add a 7. So I'm adding 2 more. So here are my answers. Next one, I have a regular polygon. Regular again means that all the angles inside of it are congruent to each other. They're all the same. 5 sides. What's the measure of each interior angle? Well, I don't know what they are yet, so I'm going to call them all x for now. They're all just x's right now. I know that I can figure out the total number of degrees inside of the pentagon using the formula that we learned in the last video, which looks like this. And I know that I can count the number of sides because I can see them. 1, 2, 3, 4, 5. So in place of this n right here, I'm going to put a 5. All right. 5 minus 2 is 3. So my equation now is D equals 180 times 3. 180 times 3 is 540. So what I know now is that all of the angles inside of that pentagon added together would give me 540. So 540 equals all 5 of my x's added together. In other words, 5x. So now to solve for x, I'm just going to divide, not by x, divide by 5. And x is going to come out to be 108 degrees. So each one of the angles inside of a pentagon is 108 degrees. Okay, and this one kind of doing the opposite, right? It wants me to, it says it's given the measure of an interior angle of a regular polygon, find the number of sides in the polygon. All right, so the formula that we've been using is this one. The problem now, though, is that I don't know D and I don't know N. I don't have any numbers to put in for either one of those, so I can't really start there. One thing to think about, though, is that any polygon I draw, no matter how many sides I give it, I could keep going, but here's a shape with 3 sides, here's a shape with 4 sides, and here's a shape with 5 sides. The number of sides in any polygon is always going to be equal to the number of angles in the polygon. So in a triangle there are 3 angles, in a square 4 sides, 4 angles, and in a pentagon 5 sides, 5 angles. The reason that matters is because I know that the total number of degrees inside of this polygon that I'm looking for is going to be 156 times the number of angles total. Okay, so the number of angles inside of this polygon I'm looking for times 156, right, because each of those angles is 156 degrees. Whatever those two multiplied together is, that's the total number of degrees. Well, what we showed over here on the right is that the number of angles in a polygon is just equal to the number of sides. And I know that N stands for the number of sides in a polygon. In other words, D is equal to 156 times N, right? So now that I know that D can be re-represented as 156N, I can take this 156N and substitute it in there for D. So my equation now, instead of being D equals 180 times N minus 2, it's going to be 156N equals 180 times N minus 2. Now my equation only has one variable, and now I can actually solve it. So I want to get N by itself eventually, but what I got to do here is go ahead and multiply. So I'm going to distribute that 180. So my equation now is 156N equals 180 times N is just 180N. 180 times negative 2 is negative 360. So again, I'm trying to get the N terms all on one side. I want the numbers on the other side. 156 minus 180, negative 24N equals negative 360. Divide, not by N, divide by negative 24 on both sides. And N is going to be equal to 360 15. N is 15. What does that mean? That means that if I have a shape with 15 sides, each one of the angles inside of that shape is going to be 156 degrees. Okay, next one, find the value of x in each diagram. Well, I'm only doing one of them here. What you should notice about this one is that the angles we're looking at now are on the outside of the polygon. In other words, these are exterior angles. Anytime I have exterior angles, if I add them all together, I get 360 degrees. Okay, so no matter how many sides a polygon has, if I'm looking at exterior angles, they're going to add up to 360. So I'm going to say x minus 11 plus x plus 10 plus 31 plus 2x minus 42. And that's really going to be it here. I'm going to have to combine like terms. I have an x, 2x, 3x, 4x. And I have negative 11 plus 10 is negative 1 plus 31 is 30 minus 42, negative 12. You don't have to do the math that way. That's just how I did it here. So 360 equals 4x minus 12. Solve the equation. And that's it. Last one. Find the measure of each exterior angle of a regular nonagon. So there's three terms there that are key to solving this problem. First one, nonagon. That just means a 9-sided polygon. So let me try and draw one here. So here is a poorly drawn nonagon. 9 sides. And if I was a better artist, the sides would be congruent because it's a regular nonagon. This will have to do. So a 9-sided shape. Regular again means that every single angle inside of the polygon is the same. So all these angles are congruent. That means that every single exterior angle is also congruent. And that makes our life a lot easier in solving this problem, because once again, no matter how many sides a polygon has, if I'm looking at exterior angles, they're always going to add up to 360 degrees. In this case, I have 9 of them, right? Sides and angles, always the same. However many sides there are, there's that many angles. So I have 9 angles that I don't know that add up to 360 degrees. And so this is a really simple one to solve. I just divide both sides by 9. So each one of those exterior angles is just 360 divided by 9, which is 40. So each one of these x's here, each one of these exterior angles is going to be 40 degrees.